Okay, so now the session is being recorded. So at least we'll catch the second half. At least we'll catch the second half. Okay, and let's go here. Let's save our spreadsheet. So save as. I'll just put this in my. So this is MBA 6020. Week 2, February 2021, 2022. Okay, so that'll be the name of the spreadsheet. I'll send this out. Okay, any questions then on the integer programming? All right, now let's go to the second handout that I gave you, and this will be nonlinear programming. So let's look at nonlinear programming here. When we were doing linear programming and we were doing integer programming, either one, we assumed that the constraints are objective functions, so on and so forth. All of those were all straight lines. All of those were all straight lines. However, what we want to look at here then, now we want to take another one here. Let me make this a little bit bigger. So the next thing that we want to do is to look at either constraints or a profit function that is not a straight line. That is nonlinear. That is nonlinear. Okay? So this is called nonlinear optimization or nonlinear programming. All right? So hopefully we understand what nonlinear programming is. When we do linear programming, we have the simplex method to solve. And if the problem is well formulated, the simplex model, even if you have hundreds of variables, like FedEx, like United Airlines, like UPS, like they do, you can come up with the correct answer. Unfortunately, for nonlinear programming, that's not true. That's not true. With nonlinear programming, there's not one way to solve this. It'd be nice if there was. And these people, believe me, people are working hard to try to get one method to do nonlinear programming, even if it takes a lot of computer time. Even if it takes a lot of computer time. Unfortunately, it's not there. Unfortunately, it's not there. And you can see here on this nonlinear programming, the blue might be the feasible region. This line is the profit function. But you can see that the blue is curved. So because it's curved, we can't use nonlinear programming. We have to use nonlinear programming. We can't use linear programming. Here's what a linear programming problem looks like. We're good at this now. We're good at this. But now we want to look at nonlinear programming. When we go to Excel, they're going to give us two options to use to solve a problem. So when you have what are called smooth functions, okay, so see this doorknob looking thing in the middle, that's our feasible region. And then these two other ones, the one with the red and the one on the left here, those are our profit functions. when they're nice and smooth like that, when they're nice and smooth, the option that we're going to use in Excel is GRG Nonlinear. You'll see where we can choose that. A second option is when your feasible regions are funny shapes. They're not smooth. Okay, they're not smooth. The option you choose now in that case is called evolutionary. Evolutionary. So I think I should try it one time. Evolutionary can solve this doorknob problem. But what about non-smooth? GRG linear can't solve this one. So evolutionary can solve both the smooth and non-smooth. Okay, so you're saying that why don't we just use evolutionary all the time? Remember that GRG nonlinear and evolutionary, they're basically approximations. They're basically approximations. And GRG nonlinear, when it's smooth like this, is a better approximation than evolutionary. Okay, so you're saying that, well, when do we use something like this? This is more common, right? In real life, this is more common. We'll solve this problem here. Okay, so you can look at this. You can look at this one right here with the graphs. So the gray area is the feasible region, and these curves there, those are the profit functions. You can see the formula for the profit functions, kind of small here. Let me make it bigger. Okay. So you can see the formula for the profit functions up here, or up here. Okay, they're curved like that. That's the way it is in real life. Many times they're curved. Whenever you have profits, the more you sell, a lot of times it doesn't go just go on a straight line. Your profits just don't go on a straight line. Your profits go up and then they kind of plateau out. They have that curve function. If that's the case, then we're going to have to use nonlinear programming, GRG nonlinear. GRG nonlinear. Okay, so any questions? Everyone have a pretty good idea of what we're going to do? Let's try a simple one right here. Let's try the simple one right here. And do you see you have x1 and x2? They're squared. They're raised to the second power. Whenever you have that, whenever you have multiplications, then you're going to have to use nonlinear programming. In real life, nonlinear programming is more common than linear programming. Okay? But most of the time, linear programming is, you can use the simplex method and get away with it. All right, so let's try now. Let's go out here and try. Okay, so let's go out here and try. Let me go back to the page here. This one right here. Let me show you how to do this one. And here comes the tips again. So the objective function is x1 plus x2. Here are the constraints. x1 and x2 have to be positive numbers. So here are the constraints. x1 squared plus x2 squared is greater than 3. x1 squared plus x2 squared is less than 10. Those are the constraints. Here's the objective functions. So here we go. So we'll do a nonlinear programming example. think I could set this up here. Now, when you do this, when you do nonlinear programming, you'll see that I'll go up there and I'll set up the equations with a lot of parentheses. So you're going to say, boy, that seems like it's sure a lot of parentheses. You're right. You're right. Okay. But basically, use all the parentheses. Use all the parentheses that I'm showing you here. So this is coefficient. This is for x1. This is x1. This is the coefficient for x2. And this is x2. Okay, so for it's the max. So for the maximization, the coefficient for x1 is 1. For x2, it's 1. Okay, let's put this up as 1. So the formula here is going to be equal to well, it's the same thing basically. Ah. So it's the coefficient for x1 times x1 plus the coefficient for x2 times x2. So nothing special there. Okay, so the coefficients for x1 is always going to be, for the constraints, it's always going to be 1. And it'll always be 1 for x2 also. All right, but here we go. It's on the constraints here. Now watch out. Here's going to come a lot of programming now. A lot of programming now. Okay, so this is going to be equal to,
Hey, Professor, real quick, I'm sorry.
the coefficient for x1 times, left parentheses, the coefficient for x2, x1 squared.
Hey, Professor.
You guys to talk louder. I can't hear you.
Oh, can you hear me now?
Yeah, better.
I was wondering if you can show me what you have as the value for F, like F 14 and G 14. Are for those? Yeah, if you could just show me the value actually for F 14, G 14, and H 14. Were those all cell reference to the previous cell?
Uh, F14 is a cell reference to F13.
Okay. And same thing
G14
for,
is given to you.
okay.
H14 is a cell reference to H13.
Okay. Thank you.
Okay. Okay. And so this is it for, and then plus G14, and then times, left parentheses, H14 squared. Right, right. Let me leave that up there for a second. Any questions? Hit enter. And for constraint number 2, let's see, the maximum is 3. It has to be greater than 3 too. And
Wait,
then for
Professor,
constraint number,
Professor, you can go back to the formula one more time. I'm sorry.
okay, make sure you got this formula correct because for constraint 2, it's the same formula. I'm just going to copy it down. Okay?
I'm good for now.
Okay, good. Thank you. I'm just going to copy it down now. Okay, and for this one, the constraint is 10. So it looks like we have it formulated correctly. Any questions? Do I need to go back to a cell? That's okay. Do I need to go back to any cells? Okay, so here we go. Now remember, this one, this constraint, this has to be greater than 3. This one has to be less than 10. How about this? Let me do this. That's what's given to us in the problem. All right, here we go. I'm going to go to data
How
analysis.
did you put your less than and greater than sign in?
Oh, that's right next to the M on my keyboard.
Oh, okay.
Yeah. I think you have to do shift.
I just thought it was like some. I don't know. I don't know what I was thinking. But continue.
Yeah. Okay, here we go. Data. Solver. Move this down. So I want to maximize, in this case, I13. So set the objective I13 to a maximum. How about this? Let me reset all of these. Okay, so we got a clear screen here. All right. So now I want to maximize I13. We set that to a maximum. by changing cells F13, H13. By changing cells F13, H13. Okay, and then we want to add this constraint. I14 has to be, now this one has, we got to change this now, greater than or equal to. Greater than or equal to K14. I14 has to be greater than or equal to K14. Okay, I want to add I15 has to be less than or equal to K15. Okay. Hit OK. All right, now here comes the tip. This one, we want to use GRG nonlinear. So right here, make your unconstrained variables non-negative. Select the solving method. Which one are we going to use? Simplex is only for straight line functions. But we want to choose now, we have a choice. GRG nonlinear or evolutionary. Because this one's not too hard, let's choose GRG nonlinear. This is the tip for here. So select a solving method. This is where you're going to choose when you're dealing with nonlinear programming. This is where you're going to choose GRG, nonlinear, or evolutionary. We won't have time to do evolutionary today, but it's just checking off the right dialog box. So this is what your dialog box should look like. Any questions? Okay, hit solve. Looks okay. Boy, look at what the answers that we come up with. X1 is 2.236. Oh, both of them are 2.236. Okay, and we plug that in. Constraint number 1, we come up with 10. Is that greater than or equal to 3? Yes. Is this one, constraint number 2, less than or equal to 10? Yes. So it looks like we went out there and we solved this correctly. But what's the takeaway for these nonlinear programming? You see that it seems like I tend to overuse the parentheses. When you're dealing with nonlinear programming, you're going to have to use a lot of parentheses just to make sure that it's clear. The second takeaway is that you have to go out there and choose the right method, GRG nonlinear or evolutionary. Okay, so in our case then, you could choose either one really. How about this? Let me just do this real quick. Let me set this back to 1. So let's just remember this number, 2.236.
Oh, I was gonna say, hey, professor, is there
Yeah,
um like a particular amount of decimals that you want to see?
doesn't matter.
Okay.
Yeah, doesn't matter. Okay. How about this? One more time. I'll go real quick. Solver, because everything is okay. But now I want to use evolutionary. Evolutionary. So I'll click on evolutionary here. Solve. Let's see what it comes up with. Yeah. See, it didn't like it. It didn't like it. Okay. So if I went back, solver, and I switch this to GRG Nonlinear, solve, there's our original one. See, so evolutionary, it's better, but it doesn't always work. GRG Nonlinear is more robust, but it's limited. Has to be the smooth functions. Has to be the smooth functions. Okay, so here's the integer programming here, and here's the nonlinear programming here. I'll make sure I'll save this, and I'll put this, I'll send it to you, or I'll put it into our announcements. I'll put it into our announcements. Okay, but I think we're out of time now. I'm sorry I didn't record the first part. That's my fault. That's my fault. But in the future, if you see that I'm not recording, please say something. Please say something so that I make sure that I'm going to record this for everyone. And I'm sorry I didn't do it today. I'm sorry I didn't do it today. Okay? So, if you have any questions, you can always email me, or remember from Thursdays from 7:30 to 8:30, I have drop-in office hours. So you can just I'll have it all set up. You can just come in, and it'll be more like a one-on-one type of situation. More of a one-on-one type of situation. And also for these problems, for the integer and nonlinear, I have other problems that I gave you. We didn't solve them. We didn't solve them today, but you can work them to make. You can try them to make sure that you know how to use the software, so that everything's going to be okay. Before I sign off, any questions? Any questions or comments? All right. So for me right now, it's the sun is still out. 5:30. It's kind of warm. It's 78 degrees and sunny in California today, Southern California. Signing out from sunny Southern California. Thank you. We will see you next Tuesday.
Thank you.
Thank you.
Thank you.
Thank you.